Prerequisite skills for pre-calculus. Skill number 4, increasing, decreasing, constant, and extrema. Let I be an interval on the real number line, and let f be a function defined for all elements of I. The function f is increasing on the interval I if and only if for any a and b in the interval I such that a is less than b, f of a is less than f of b. In this case, what we are is we're defining certain inputs for an interval. If the later input has a higher output, then we say that the function is increasing. But this is only if that is always true for any pair of points in the interval. Let's consider an example. The stock price of essential utilities from 2019 through 2020. If we look carefully, we can see that from December 1st until March 1st, the stock price increased. We would say that on the interval of December 1 to March 1, this function is increasing. Notice that when we list the interval for increasing, we are listing the input values, not the outputs. We are not saying that it is increasing from $43.01 to $43.76. No, we are telling you when it is increasing. That is an important concept. If we pick any two dates in this span between December 1st and March 1st, the stock price will be higher for the later date than for the earlier date. This is consistent with the definition of increasing, where we can choose any two dates in the time interval such that one date is later than the other. The later date will have the higher stock price. Let I be an interval on the real number line, and let f be a function defined for all elements of I. The function f is decreasing on that interval if and only if for any a and b in the interval such that a is less than b, f of a is greater than f of b. Again, let's consider essential utilities. In this case, if we look at March 1st through September 1st, on that interval we would say that the stock price is decreasing. So the interval of decreasing is March 1 through September 1. Again, we're telling you when it's decreasing. We are not saying it's decreasing from $43.76 to $39.35. Anytime you're asked, when is a function increasing or when is it decreasing, you are listing the inputs. If I pick any two dates in this interval, what we see is that for the later date, we have a lower stock price. That is again consistent with the definition. For any two dates in that time interval, the earlier date is higher, the later date is lower. That is the definition of decreasing. Let I be an interval on the real number line, and let f be a function defined for all elements of I. F is constant on the interval if and only if for any a and b in that interval, such that a is less than b, f of a equals f of b. For essential utilities, we'll notice that from September 1 to September 11th, the stock price is level. It is constant. So our interval on which it is constant is September 1 to September 11th. If we pick any two dates in that time interval, the stock price will be the same for both of those dates, no matter what pair of dates we choose. So that is the interval on which the stock price function is constant. Again, this is consistent with our definition. Now let's talk about extrema. A function f has a local or relative maximum at the point a comma f of a if there exists an open interval I containing that a value such that for all values in the interval, f of a is greater than or equal to f of c. If f of a is greater than f of c for all values of c in the domain of the function f, then the function f has a global or absolute maximum at a comma f of a. Consider the stock price for Carrier Global Corporation, which broke off from United Utilities earlier this year. This is the entire span of the price of that stock. from when it broke off until just recently. In this case, if I'm looking for local or relative maximums, I can see that on the interval just before April 3rd to just after April 3rd, that this is locally the maximum. On that interval, if I pick any date in that interval, the price of the stock will be lower than the price at April 3rd. So this is a local or relative maximum. Look at June 8th. Again, we can look for an interval around that date. In that interval, picking any date, it will be lower in stock price than on June 8th. And lastly, let's look at August 26th. Again, we can see that there's an interval around that date where the price of August 26th is greater than the price of all the dates in that interval, making it a local or relative maximum. Now, as for the absolute or global maximum, in this case, we have to look at the entire domain. In this case, the entire span of the price of this corporation. In this case, when we look, August 26th is higher than the price for the entire span. So the interval in this case being the domain of the stock price, this is our global or absolute maximum. A function f has a local or relative minimum at a comma f of a if there exists an open interval I containing a such that for all c in that interval, f of a is less than or equal to f of c. If f of a is less than or equal to f of c for all c in the domain of the function f, then f has a global or absolute minimum at a comma f of a. Again, let's consider Carrier Global Corporation. In this case, if we look for local or relative minimums, we can see that there's an interval of time from just before March 23rd to just after it, where that is the lowest price in that interval. So that is a local or relative minimum. Look around May 5th. Again, we can see that there's an interval, there's a time span around that date where May 5th has the lowest price in that span. And lastly, if we look at June 26th, we can see that there's an interval around June 26th where that is the lowest price for the stock. In each case, these are local or relative minimums. Relative to the dates around them, they are the lowest price. Again, we tell you the dates and the price for those. Now, for the global, we have to think about the entire graph. In this case, what is the absolute global minimum value of this stock from its beginning when it broke off until just recently? In this case, we can see that the lowest price is happening at March 23rd. $11.54 is the absolute or global minimum price for Carrier Global Corporation over its entire lifespan. Now let's take this and let's apply it to a traditional function you might see in a math class. For the following piecewise function, let's identify the intervals of increasing, decreasing, constant value, and classify all the extrema. First of all, let's graph the piecewise function. You'll notice the graph consists of 4 pieces: a parabola, an absolute value function, a horizontal line segment, and then a line of positive slope. If we're looking first for the intervals where it's increasing, notice that the graph from -4 to -2 is increasing. If we pick any 2 values of x in this interval, the larger value of x will have a larger y value. The same thing with the interval from 4 to 6. If we pick any 2 x values in that interval, the larger x value will yield the larger y value. And lastly, if we look at the interval from 8 to infinity, choosing any 2 x values in that interval, the larger x value will yield the larger y value. And therefore, we can say the function is increasing on those 3 intervals. Where it's decreasing, we would say from -infinity to -4. Again, because if we choose any 2 values of x in that interval, the larger value of x will yield a lower value. The same thing with the interval from -2 to +4. Choosing any 2 x values in that interval, the larger x value will always yield the smaller, the lower y value. As for intervals where it's constant, if we look at the interval from 6 to 8, this function is constant. Choosing any two x values in that interval will yield the same y value, no matter what pair of x values we choose. Therefore, that's the interval where the function is constant. If you piece together all of these intervals, you'll note that we cover the entire number line except for the points where we switch from increasing to decreasing, or increasing to constant, constant increasing. Now let's think about the extrema. We can see that there are some extrema on this graph. Let's start with the local. So the relative or local minimums occur at -4, -3. We can see that there is an interval around that such that that is the lowest point relative to all the points around it. Similarly, we can say there's an interval around the point 4, -5. In that interval, relative to all the points around it, that is the lowest point. That is the minimum. And so our minimum value is -5 for that interval. The relative maximums, in this case, we can look at -2, -1. We can find an interval around that such that in that interval, relative to all the points around it, in that interval, -2, 1 is the maximum. As for the global or absolute, we have an absolute minimum at 4, -5. For the entire domain of this function, 4, -5 is the lowest point. The minimum value, the absolute minimum for this function is -5. As for an absolute maximum, we can see that there is no absolute maximum. Although we had a local maximum at -2, 1, it is not the highest point over the entire span of this function. And therefore, there is no absolute maximum.